Okay, welcome to another Orbiter 2010 video. And in this video, we are once again going to take a look at IMFD, continue learning how to use it. Dimitri is here with me again, and we all appreciate him sharing his knowledge with us. Now, in the last couple videos, we looked at how to go from the Earth out to the Moon, doing sort of a basic look at IMFD. And we're going to look at that again, and in fact, we're going to use the same scenario that we used from a save point in that flight. Before we jump into that, though, there is a very important point that we need to get into in the IMFD configuration file. When in the previous video, it didn't really matter how you had your non-spherical gravity sources set, so we didn't really even get into that when we were talking about the configuration file. But in this following example, we're going to be using IMFD's map program. And that map program, it's basically consider this a requirement. This isn't just a suggestion. This is a requirement. You need to go into your IMFD config file, and down here where it says non-spherical, the default option for that line is set to 1, which is automatic. Unfortunately, the automatic setting doesn't work very well, so we need to actually change that to the number 2. You can see here at the end it says 2 is always on. We need to make sure that we have that set to 2. And Dimitri, do we also want to suggest that the legs per frame gets set to 64?
Yeah, the default file I think has it at around 10, so you want the most legs per frame will give you a slightly more accurate, let's say, prediction, and also infused with the adapt tolerance over here with this number, because you can see the lower value it has the highest accuracy. So these two together work better. This at the highest value it can have, which is 64. And this somewhere around the middle, at around 4, and it's going to give you a very nice compromise between the lag that you get when you connect two interplanetary IMFDs together to see the map, and the accuracy of the prediction that the map makes.
So basically, the more accurate, I was going to say, the more accurate it is, the more lag you get, but the less lag you get, the less accurate it is.
Exactly. So we want to make a compromise somewhere around the middle, where we get an accurate prediction in the map program, and also to have it set a relatively fast connection between the MFDs. This will make more sense for our viewers when we go into the flight itself.
Yeah. So
but for now, all you need is to set the legs per frame to 64 and adapt tolerance here, this number, to 4.
So what we're looking at here should be the default configuration file. So again, we'll just run through the 3 options. Non-spherical should be set to 2. And let me actually bring up my configuration. So non-spherical should be set to 2, legs per frame 64, and then
you also have the leg size to 1, because I think in the default config it's set to 3.
Yeah.
Set it to a smaller.
Yep. So let's run through it again. Non-spherical to 2, leg size to 1, legs per frame to 64, and then the adapt tol, set that from the default is 8, so set that to 4 as well. And then save your configuration file. And if you happen to have Orbiter already open, make sure, of course, that you exit out of Orbiter and start it back up, because this file won't be read until you restart Orbiter. Then the other thing that you want to check in order to follow along is go into your parameters in the Orbiter Launchpad, and under the perturbations, make sure that non-spherical gravity sources is checked, at least to follow along with this video. If you want to then go back later and uncheck it for other reasons, that's fine. But in order to be able to follow along, you absolutely must have this checked, because otherwise you're going to find that in the map program, the predictions are just bouncing all over the place and you can't follow along. Okay, now having said all that, let's jump back into that scenario that we had there, and it'll take a second to load up. And once it loads up, I'm actually going to have to bring up the scenario editor, and we're going to have to rewind time a little bit because we're too close to the time to the burn, so we won't be able to explain how to use a map in IMFD and everything. Okay, so that's the scenario. Let's bring up the scenario editor, and we're just gonna, again, we're gonna rewind time a couple thousand seconds just to make sure that we have enough time to do this.
1000 seconds is enough, because anything more than that and you will not get a prediction from IMFD.
Okay, so we have the TEJ there. You can see it there. Okay, so in the previous video, again, we looked at setting up this target intercept program so that we could get out to the moon. And by default, this program has you essentially diving straight into the center of the moon. And of course, we could do some things here, but it's better if we use a combination of a couple of other programs. So let's jump into that. What do we want to use here instead of target intercept?
Yes, we're going to use the delta velocity program of IMFD connected to the map program, which is going to give us, it's going to show us our trajectory. And the prediction in the map program is very accurate in order to be able to adjust our variables and arrive at the moon using a single burn and be already aligned with the base and have the period altitude that we want.
Okay, so on the left side then, we're going to power up this, and we're going to select to bring up IMFD, and we're going to press the
Hit the
menu button.
menu button over here.
Let's make a note
Again.
here. I was going to say, let's make a note here in the upper right. You'll see that this says ID 0. In a moment, we're going to share these MFDs. So while we're looking at that, let's talk a little bit about that. How does this ID 0 stuff work?
You can see here the operation mode, and when you press this button, this PC button, it asks you to enter the ID of the MFD that you want to share. So the left MFD has the ID 0. If you press here the menu on the right MFD, you can see that the right always has ID 1. So if I want to share the data from here to here, I can simply press this button and press 0. If you want to do it the other way around, suppose you had you were setting up the burn over here and you had the map over here, you simply press the page button and you share the data from this side. It depends where you want to make the adjustment and where you will have the map. Wherever you have the map, you will share from the other side.
I typically,
in this instance,
I typically, since I read left to right, I think it tends to make sense to kind of set things up on the left side and then have your predictions on the right side. That's kind of how I think. And if we think about this in terms of transects, a lot of times you'll see me in my videos, I'll set up maneuver mode on the left side, and then on the right side we have our encounter view. That's basically the same thing that's going on here. On the left side, we're going to be using the Delta V program, which is kind of like setting up a maneuver. And then on the right side, we're going to be using the map program, which is very similar to having an encounter view.
okay. So for now we have not shared everything, and we had the course program already set from the previous video to go to the moon, but this burn of course took us straight at the center of the moon and we needed corrections. What we're going to do is we're going to copy this burn over here in the delta velocity program. So we can go to course.
Do we want to look at the BV on the right side first before we bring up the Delta V on the left?
It's not really important. It might be a good starting guide to see. I already pressed it, and you can see that burn, this 3136.50, how it divides in prograde, plane change, and outward. Actually, it's inward in this case. And you can make a note of these numbers, but you have to remember that this burn took us to the center of the moon. So it's not they're not vital to the burn that we're going to set up over here. As a rule of thumb, as long as your here this number, essentially the relative inclination to the hypothetical orbit is 0.01 or less, you can simply use this number, the delta V, as the prograde number in the delta velocity program, and then you can adjust the variables from that.
Okay.
So first, Okay, let's go to the course program on the left and select the delta velocity program.
Okay, so on the left side, we're going to bring up course, and then we'll use the previous next buttons to go down to delta V. Would have actually made more sense to go previous because it would wrap around. And then set, and now we have delta V.
Okay, now you can copy the time of ejection and the forward, the prograde, from these numbers over here, this one and this one.
Okay, so we're going to go next, and we can see we have TEJ, and we're going to hit set, and we're going to put in this value, and it doesn't have to be precise just due to the fact that we're going to be making adjustments here anyway, so don't worry about trying to time this down to the, down to the 10th of a second or anything like that. And then the next thing...
1-2 seconds difference makes no matter. We'll adjust the number anyway.
Exactly. And then we're going to go down to the delta V forward, which is basically prograde. Hit set, and then we're going to copy the number that we see over here, which is 3135. Hit enter, and now we basically have a copy of the target intercept data over on the delta V program.
Okay, so now on the right side, we can forget about that plan of it, because this is what we're going to actually fly. So you can go to the menu button and share the information from this IMFD.
Okay, so now menu, and now we're going to share 0. So we're sharing the left side with the right side.
And now you can use the map program.
Okay. Do we want to go to configuration and target Brighton Beach first, or?
Yes, that's a good catch, because we would have to do it later anyway. Yeah, it's better to do it now when you are in this page.
Yeah, since we're already.
Our
Yep.
target on the moon is Brighton Beach, so let's set it from now.
Yeah, since we're already here on this page, we're going to have to go to this configuration here shortly, so let's just do it now. And we'll go down to the next for landing target, and then set, and then just type in Brighton Beach, like that. And now back to the menu and over to the map program. And what are we looking at? This is confusing.
Yeah, this is actually our orbit. This is the same as this, our orbit around the Earth, but without the hypothetical trajectory. You can. The first thing you need to do is to target the moon. That's where we're going.
Okay, that makes
so you
sense.
Can press the target button and then select the moon.
Okay, target moon.
Okay, so now you have the moon, or the orbit of the moon over here. The Earth is right in the middle, and this green thing over here is up. You can change the projection if you want to go to self, get a nicer bird's eye view from the top of the of your orbit, essentially. And the ISO button over here removes the auto zoom. It's a good practice to keep it off, because when you enter a hypothetical trajectory and you want to see it over here, if it stretches out beyond the moon, it will automatically zoom out to show you the whole trajectory. So you are going to have to set it again with zoom in until you find the setting that you want. By keeping it off, it stays the same, and you can manually set it with zoom in or zoom out with these two buttons. The other thing that you can see that these variables are just one of 2 pages. So you can switch to the next page, and now you can see the SOI just going to show you the sphere of influence. This is the sphere of influence of Earth and the Moon. The intercept button simply shows you where you intercept with your target if you have a plan of intercept, and this is what you do with the plan. You hit the plan over here, and this is the most important part, because it shows you this trajectory, the hypothetical trajectory over here, where it is going to get you. The next thing that you need to set is, you can see that you have 3 different options over here. One is periapsis at the Earth, the other one is periapsis at the Moon, at our target, and the third one is going to be probably apoapsis from the Earth, but we are not going to use that. What we want to see over here is the periapsis at the Moon, because this is where we want to go. And we select that by going back to the first page of variables over here, and hit the cell button at it until you see periapsis reference moon, this one. Now, we need to adjust these variables, the time and forward plane and inward in the delta V until we get a periapsis altitude of about 20 kilometers, and we can also see by hitting the mode button over here how many degrees off plane we're going to be to Brighton Beach, and we want to set this to as close to 0 as possible. So these two variables need to change at the same time, getting this one to 20 kilometers, the periapsis altitude, getting this one less than half a degree, by changing these variables over here. So you want to start doing that?
Yeah, okay, so over here on the right side, we've got the map program up, and this is effectively showing us our encounter type of view. And now on the left side, we're going to adjust some of these variables, and we're going to watch what effect that has over here on the right side. And the two things that we're looking for are the periapsis altitude at the moon, that's the PEA here. And again, just as important to note that this is reference moon because we have PE 2 of 3. If for any reason that if you have that on PE 1 of 3, then the PEA that you're seeing here isn't for the moon, rather it's for the Earth. So you need to make sure, make sure that you press a page over here to get, you go page back and forth between these variables, and then SEL to go from PE 1 of 3 to PE 2 of 3, so that we're now looking at the periapsis for the moon. And then we also have the angle down here, and I believe we brought this up by using mod. So if you press mod on this page, you'll go around and just like everything else, it goes in a circle. So by default, you're looking here where you just have the PEA and the next node down here. But if you press mod, then we have the PEA and the angle. So that's how we get to that data. And now on the the left side rather, we want to start by going to the TEJ, and we'll just plus or minus and watch the PEA we want to get it down to our target altitude, which is going to be about 20 kilometers. So let me hit minus, and minus is helping. So I'm just going to keep clicking away on that until it won't go any lower.
You can also get a better look at your trajectory relative to the moon by hitting the center button and changing the center of the focus of this map.
Yeah, let's
right
do
now
that.
The center is the Earth.
Okay.
You can switch it to the moon, and actually instead, if you press center moon right now, it's going to show you this, so it's not going to be very helpful. But if you press center, I already click on that, and you press P hyphen, is it? What is the
yeah, dash hyphen.
moon, you're going to see the periapsis of the trajectory, of the hypothetical trajectory, and not right now.
Okay, so we just press center, then P hyphen moon, press enter, and we kind of want to zoom in on that a little bit, don't we?
Yeah.
So then Z plus, and we just want to zoom way down, and we can get a better look at our path out here toward the moon, and we can see clearly that currently we're pretty far off. So now we want to continue our adjustment on the TEJ.
I'd say first, if you want to hit pause or use the scenario editor, go a couple of minutes back, say to around 300 seconds, because we're already too close to the burn and we won't have time to adjust the variables.
Okay, so we're back here. Actually, do we want to go to about 600 seconds?
No, I think we're okay.
Okay, so we were about 400 seconds from the time to the burn. And again, sometimes it just takes a while to explain things, so we kind of have to keep rewinding the clock a bit.
Exactly. I mean, when you're doing this by yourself, you can set up a lot faster. You're just playing around with the variables, and you're looking at two numbers over here, this one and this one.
Yeah, and once you're familiar with it, you'll do it like that, and it'll take 5 seconds or 15 seconds to set up instead of 7 or 8 minutes to explain. So here we are, we're getting, time's ticking away, so let's press minus, and you can see that that's not helping. It's actually raising the PEA, so let's go the other way with it. And we're just looking for the point where, and that's bottomed out. So right around 4,000 kilometers is about as low as we're getting just by adjusting time. So then we want to go forward to the DVF, which is basically prograde, and we do an adjustment there. But it turns out that if we just have 1x, it'll take a long time. So we want to click ADJ to change that from 1x to 10x. And now we can use plus minus and see what happens. You can see that that helped a lot. It cut it in half. So let's plus one more time. Now we're down to 640. Plus one more time. Now we're right there below the surface. So let's now make the adjustment at 1x and take out just a little bit. So I'd say right about there, maybe. So we have an option of 48 or 14, but I bet we can probably go back to the time at this point.
Actually, you went from prograde to the moon. You actually switched to what seems about retrograde. Actually, it's almost a polar orbit. You can see your inclination over here, your equatorial inclination when you arrive. It's 80 degrees.
Yeah.
See if you can go add a little bit less of delta V.
Okay, a little bit less delta V, and our EQI is going down.
Actually, what we're interested in is this number.
The angle.
Right here. Yeah.
Okay, let's see. Is that going? Yeah, that's going down. So we're almost.
Okay. Now let's put in some inward to bring it actually a little bit more to the inside. This is the same in TransX. At first, when you change the variables, you don't know which one to change, and it takes a lot of time. But with more practice, you actually have already an intuition of which variables help and which don't at a given situation.
Right. So it's kind of a matter of experimenting around a little bit. You do that a lot in TransX as well. Just kind of what happens if I do this, what happens if I do that. So we're just putting in a bit of inward. At this point, you can see the angle to Brighton Beach coming down, and that's how far off from the base will be. We want to get that really close to zero, and that's about as low as it's going to get without going to some other variable.
You can go back to the prograde, and I'm referring to prograde. As you will see here, me always calling this as prograde, because I'm used to TransX. This is prograde, this is plane changes, this is the opposite of TransX. This is inward instead of outward.
Right. So back here, at basically prograde, then we'll do plus is helping to bring the PEA down, but it's raising the angle. So we kind of want to go back and forth between DV.
We can use, yes, exactly.
All right, so let's bring down the PEA a little bit more. Now let's go to the inward. And actually do an adjustment. So that's going the wrong way. Let's go backwards. So we'll probably have to go a little bit higher on the angle. And
exactly,
then,
let it go the other way, and then you give it some more
yeah, then
prograde.
When we come back with prograde, we'll... that's a bit too much. Let's go down to one adjustment. So we're just working on getting the variables here.
Get the periapsis closer to 20. Sometimes you do you first do a variable and then you try to change the other one. Sometimes it helps if you do it the other way around.
Yeah, so we'll get the... that's 10's too much of an adjustment. So let's get the periapsis closer to 20. Oh, right about there. And now DVI. See, the DVI needs that 10 for sure.
Mm-hmm. You can also try a little bit of plane change. So this looks pretty good. But now when you give it more prograde, it's going to change the angle.
Yeah, and we're running out of time here if we want to get this burn done. So do we want to try a little bit of plane change? to see if it'll help with the PEA. And now down to DVI. That's the wrong way. We're pretty close here.
Yeah, I mean,
51
definitely
kilometers.
fly this map.
Yeah, and just due to
You
the...
can go ahead and fly this.
Yeah, let's fly this just for the fact that we're only 30 seconds away from the burn. But you get the idea. Just by going back and forth between these three variables, you'll eventually be able to adjust so that you'll have your PEA at about 20 kilometers, and you'll have your angle here. Let's just see if we can just, in the last couple seconds here, get that angle a little bit lower. About right there. And then to burn the burn, we're going to have to quickly just say press page, go to BV, and then AB, just simply because we're out of time. And then IMFD, just like it did before, it will automatically line things up and it will complete the burn. And you can even press T to warp time forward to get through the burn more quickly, and IMFD will come back to 1x when it gets close to the end of the burn, so you don't have to worry about overshooting or anything like that. And it will also stop the burn on time, so you don't have to worry about actually pressing the asterisk key on the numeric pad to stop the engines or anything like that.
Okay, on the right side you want to remove the plan now and see the actual trajectory.
Okay, so that would kind of be like turning maneuver mode off then, would it be?
Exactly. Hit the page button again on the right side. Yeah, you have already. And press the plan.
Okay. And now this is the actual, what's actually going to happen.
Trajectory. And now you can make, if you want, a slight adjustment with a linear RCS to fix those numbers over here, because you see it's not exactly
right
what we had said, but there is also a little bit of delta V left here on the left. But you can use a linear translation and adjust those numbers. Give it a little bit forward, left, right, up, down until you get the values where you want them.
Yeah, just like with TransX, when the burn's complete, usually you just want to, manually, press the buttons one way or the other. Maybe a little bit of up translation to bring the angle down, a little bit more forward brings the periapsis. Now the periapsis right there at about 20 kilometers, but the angle's a bit off, so maybe let's see what pressing so a little bit of up translation is also helping bring the angle down. And this is probably not even a whole meter per second that this equates to when you press these buttons 5 or 6 times.
Yeah, you can also try a little bit left or right.
Yeah, I'm working with those as well. So, but you get the idea. Basically,
anything less than half a degree, either minus or plus, and this around 20 kilometers. I mean, 40 is also just fine to get them on. The cool part is that this prediction is pretty accurate. You're going to arrive at this trajectory and this periapsis almost pretty much at what this prediction says, and it's going to be, 3-4 days later than where we are right now.
Okay, that's excellent, and we're coming up again at about 30 minutes, so let's go ahead and end the video here and pick up in the next part where we'll go ahead and warp time forward and see what kind of small mid-course corrections we need to make. Keep in mind that the last time we had like 168 meters per second, and this time we should just have 5 or 6 meters a second.
Yeah, exactly. Less than 10 meters per second the corrections, and we're going to be exactly aligned on the base when we're going to make the lunar orbit insertion burn.
That's very cool. It's very cool that it can be that accurate. Okay, so if you like this part of the video, please hit that like button down below. Check out the link in the description. I'll put a link to Dimitris' YouTube channel. Check that out and leave him a comment. Let him know that you really appreciate him taking the time to sit here this afternoon and help us all learn how to use IMFD, because you can see how powerful this program really is. And we'll pick it up in the next video, so I will see you in the next part. Okay, welcome to another Orbiter 2010 video. And in this video, we are once again going to take a look at IMFD, continue learning how to use it. Dimitri is here with me again, and we all appreciate him sharing his knowledge with us. Now, in the last couple videos, we looked at how to go from the Earth out to the Moon, doing sort of a basic look at IMFD. And we're going to look at that again, and in fact, we're going to use the same scenario that we used from a save point in that flight. Before we jump into that, though, there is a very important point that we need to get into in the IMFD configuration file. When in the previous video, it didn't really matter how you had your non-spherical gravity sources set, so we didn't really even get into that when we were talking about the configuration file. But in this following example, we're going to be using IMFD's
sensor for our viewers when we go into the flight itself.
Yeah, so
But
let's
for now, all you need is to set the legs per frame to 64 and adapt tolerance, here this number, to 4.
So what we're looking at here should be the default configuration file. So again, we'll just run through the three options. Non-spherical should be set to 2. And let me actually bring up my configuration. So non-spherical should be set to 2, legs per frame 64, and then
you also have the leg size to 1, because I think in the default config it's set to 3.
Yeah.
Set it to a smaller.
Yep. So let's run through it again. Non-spherical to 2, leg size to 1, legs per frame to 64, and then the adapt tall, set that from the default is 8, so set that to 4 as well. And then save your configuration file. And if you happen to have Orbiter already open, make sure, of course, that you exit out of Orbiter and start it back up, because this file won't be read until you restart Orbiter.
It's the adapt tolerance over here with this number, because you can see the lower value it has the highest accuracy. So these two together work better. This at the highest value it can have, which is 64. And this somewhere around the middle, at around 4, and it's going to give you a very nice compromise between the lag that you get when you connect two interplanetary IMFDs together to see the map, and the accuracy of the prediction that the map makes.
So basically, the more accurate, I was going to say, the more accurate it is, the more lag you get, but the less lag you get, the less accurate it is.
Exactly. So we want to make a compromise somewhere around the middle, where we get an accurate prediction in the map program, and also to have it set a relatively fast connection between the MFDs. This will make more.
Then the other thing that you want to check in order to follow along is go into your parameters in the Orbiter Launchpad. And under the perturbations, make sure that non-spherical gravity sources is checked, at least to follow along with this video. If you want to then go back later and uncheck it for other reasons, that's fine. But in order to be able to follow along, you absolutely must have this checked, because otherwise you're going to find that in the map program, the predictions are just bouncing all over the place and you can't follow along. Okay, now having said all that, let's jump back into that scenario that we had there. And it'll take a second to load up. And once it loads up, I'm actually going to have to bring up the scenario editor. And we're going to have to rewind time a little bit, because we're too close to the time to the burn, so we won't be able to explain how to use a map in IMFD and everything. Okay, so that's the scenario. Let's bring up the scenario map program. And that map program, it's basically, consider this a requirement. This isn't just a suggestion. This is a requirement. You need to go into your IMFD config file, and down here where it says non-spherical, the default option for that line is set to 1, which is automatic. Unfortunately, the automatic setting doesn't work very well, so we need to actually change that to the number 2. You can see here at the end it says 2 is always on. We need to make sure that we have that set to 2. And Dimitri, do we also want to suggest that the legs per frame gets set to 64?
Yeah, the default file I think has it at around 10, so you want the most legs per frame will give you a slightly more accurate let's say, prediction, and also in used with